Hey, this is Dan Abbott. I'm going to review on Chick's Garage, the assignment in AEDD 100 Print Reading, the calculation of the concrete required for the footing, the wall, and the slab, as well as the number of sheets required for the roof and the roofing required, because a number of people had difficulty with that. And in a couple cases, had thousands of dollars too much material that you've calculated. So we're looking now at a cross-section of the foundation. That's where I'm going to start. And by the way, when it says take off, a takeoff is how much material is needed for a particular application. We have the foundation wall here, 3 feet 8 inches high from the footing, 8 inches deep. It sits on a footing that's 16 inches wide. 1 foot 4 inches is the same as 16 inches. It's 8 inches thick, and it's got a slab that's 4 inches. The slab goes out to the inside of the wall, so it's not the same size as the outside of the wall. The footing goes on the outside, and the most accurate way to calculate this is to start by breaking down into the wall, the slab, and the footing. If you look at the wall from the top in a plan view, it's 28 feet by 24 feet. That's the face of framing. So we're going to calculate the overall area as though we had only 24 by 28. Then we're going to calculate the area of the inside rectangle and subtract that. That will give us the area of that top part of the wall all the way around. So to begin with, I'm going to take 28 feet and multiply that times 24 feet. And we're going to come up with, look over here, 28 times 24 equals 672. That's 672 feet squared. Don't forget to write down your units now. So feet times feet is feet squared. Now we're going to subtract from that the inside rectangle, which is 26 feet 8 inches. In other words, if you take 28, subtract 8 inches from this side and 8 inches from that side, you're left with 26 feet 8 inches. So we're going to say, and by the way, 8 inches divided by 12 inches per foot equals 0.666667. Let's just go with 0.67 feet. Inches cancel out, we're left with feet. So now we can have a decimal value for feet, 26.67. I meant to make a 7 there. Feet times 22.67 feet equals. Now we go back and we do the math on that. So 22.67 times 26.67, and that equals 604.61. So 604.61 feet squared. Now I'm going to subtract those two numbers. And we're going to take 672 square feet and subtract 604.61 square feet from that, and then we'll have a total. So we'll come over here and do that. 672 minus 604.61 604.61, and that's going to equal 67.39 square feet. So that's the total square footage of the top surface of that wall. Now that's square feet. We want cubic feet. So now we're going to multiply that times this overall height. The overall height is 3 feet 8 inches, so that's 3.66666666, or 3.67. So we multiply the total area of the top by 3.67 feet. That's not square feet, that's just feet. And that's going to give us 3.67. We're multiplying. That's going to give us 247.32 cubic feet. So that's the volume of that wall. But don't forget, there are 27 cubic feet in every cubic yard. So we have to divide that number by 27 cubic feet per yard. When we do, we end up with 9.16 yards. 9.16 yards is how we're going to measure the concrete. I think I might need to focus this again. Try that. Refocus it. Looks a little better. So 9.16 yards is what we need just for the wall. I'm just going to leave that number. I'm not going to round it at this point. Instead, what I'm going to do is calculate the others, add them together, and then round up to the nearest yard. But that's how many yards we need. Now, if you did the calculation, you came up with hundreds of yards, that's because you're actually still in cubic feet. That would make a huge difference. The difference in cost between 9 yards and 247, that's a really big difference. Now we go over to here, the slab, and that's actually a lot easier, but what many of you did was assume that the slab was also 28 feet by 24 feet, but the slab, as you can see, doesn't go all the way out here. So it's the overall dimension minus 8 inches all around. So it's the same as that value right there. Well, we've already calculated that value right there, and we did that right here. That inside is 604.61 square feet. So we know that because of the same values. Now, what do we do to get the volume? We multiply that times 4 inches. Well, 4 inches divided by 12 inches per foot equals 4 divided by 12, 0.3333333. So we'll just call it good. So that's 0.33 feet is what represents 4 inches. So we'll multiply this times 0.33 feet. And when we do, let me go clear this. So I have the 604 times point, and it really is like 0.33333. It keeps going. But now we end up with 201.33333 cubic feet. And it's cubic feet because we have square feet times feet. Now we're also going to have to then divide this by 27 cubic feet per cubic yard. So we take that number, divide by 27, and we get 7.456. Let's just go with 7.5. So we're going to end up with 7.5 cubic, not feet. Sorry, 7.5 yards. So we started over here, we have 9.16 yards, and we have 7.5 yards. Now we have to go and get the footing. Do the footing the same way we did the wall. First you have to determine what the outside area is. Now we've already done that for the wall, but now we have to do it for the footing. Kind of cut it off over here, I'm afraid. But that's the overall width of the footing because the footing is wider, right here, wider than 28. And it's wider by 4 inches from here to here. Oop, can't see that. 4 inches from here to here on either side. So instead of being 28, it's 28 plus 4 plus 4, or 28 feet 8 inches. And that's what we have right there. And then up and down, we have 24 feet 8 inches for the same reason, 24 plus the 8 inches. So now we have to convert that into decimal. So it's 28.67 feet times 24.67 feet. Back over here and do the math. 28.67 times 24.67 0.67 equals, that can't be right. This is one of those things about guessing in advance. And one of the reasons I'm doing this is because I'm picking these with my mouse, and what I'm going to do instead is just move over and actually use the number pad. So we've got 28.67 times 24.67, and that equals 707. That looks a lot better. So 707.28, let's go 29 square feet, because it's feet times feet. That's the overall on the outside. Now we have to subtract the inside to get the area of just the top surface of the footing itself. So in order to do that, we have to multiply 22 feet times 26 feet to come up with the area of the inside. So we'll come back over here and we'll clear that. So we've got 22 times 26, 572. And again, that's 572 square feet. So 707.29 square feet minus 572 nothing square feet leaves us with, we come back over here, we'll clear everything out. So we're going to go 707.29 minus 572 equals 135.29 feet squared. Now that gives us the total area of the top of that. Now what we need to know is how deep does that go in order to come up with the cubic feet, and the depth of that is 8 inches. You can see that right over there. So we're going to multiply that times 8 inches, which is 0.66666666 square feet. Let me do that one more time. Alright, so we're going to take that value and we're going to multiply it times 0.67 feet. That's going to give us cubic feet. So multiply that times 0.67 and we end up with 90.64 cubic feet, and then we have to divide that value by 27 cubic feet per yard. So we're going to divide that 27 cubic feet per yard. And that gives us 3.35. Let's go ahead and make that 3.36. So this one's going to be 3.36 yards. Over here we've got 7.5 yards, and over here we got 9 yards. So let's add all those things up together. All right. So 9.16 plus 7.5 plus 3.36 equals 20 and a little more. So we're going to probably call that 21 yards. Or you could just say 20.0 yards. Now let's take a look at the sheathing. So what we're looking at now is the roof. And the roof here, this is something where, you know, you were given a roof pitch, that distance right there, 12.8. What that means is for every 12 inches of run, the distance from here to the center line, because what we're doing is creating a right triangle here. So from here to here, for every foot, 12 inches, it's going to go up 8 inches. So in order to find out, you know what the length of this is, because the width of the building is 24. So it's 12 feet from here out to the side of the building plus an additional foot, because you were told that there's 1 foot of overhang on each side. So 12 plus 1 is 13. So we're really just recreating a right triangle. And we know that's 13 feet. Well, if we know the pitch is 812, we can calculate the height here, which is not going to be 8, it's going to be 8 inches per foot. So 8 inches times 13 feet, 8 inches per foot now, times 13 feet is going to give us how many inches? 8 times 13. So there's 8 inches for every foot, so there's 104 total inches of rise. Divide that by 12, and we get 8.6667. It keeps coming up, doesn't it? So the height here is 8.67 feet. Now, the reason that we need to know that, and you look up here, and I've calculated that up here as well. The reason we need to know that is if we know it's 13 feet from here to here and 8.67 feet from here to here, those are the two legs of a right triangle. Square that, add that to the square of this. That will give you the square of the slope, which is the hypotenuse. Take the square root of that number and you'll get the slope. So 13 feet squared plus 8.66667 squared equals the slope squared, which means the slope squared is 244.112 square feet. Take the square root of that number now, and you get 15.6740, which is 15 feet 7.5 inches. The distance from here to here is the same as the distance of here to here. We've just created an auxiliary view. That's what that is right there, looking straight down at the roof. So if we're looking at the roof like that, 90 degrees down, that's the area of one roof panel. There's one here, and there's another one over here. So when we calculate this and come up with that area, we can use that to determine the number of sheets we need, and we can use that to determine the number of shingles we need. Then we have to double it because there's two roof planes. So 15 feet 7.5 inches is 15 feet 0.624. So we're going to multiply 15, that's the overall length of that, that's the roof slope. Going to multiply 15.62 times 28, the feet in both cases. That'll give us the area of one roof plane. The area of one roof plane is 437.42472 square feet. Now, that's one. How many square feet are there in one sheet of material? What we're going to do is we're going to put sheets of plywood or sheets of something on that roof, and those sheets measure 4 feet by 8 feet. 4 feet times 8 feet equals 32 square feet, which is where that number came from, right there. Every sheet covers 32 square feet of area. So if we know the area of one roof plane is 437, we can divide by 32 square feet per sheet. That gives us about 14 sheets. You can't have, you got to go up if you're going to round on this. So we need 14 sheets for that side. That means we need twice as many for the whole roof, so we need 28 sheets total. So the number of sheets of material we need is 28. Now as far as shingles go, the shingles, one bundle of shingles is 29 individual shingles. One bundle covers a third of a square. A square, in building terms, equals 100 square feet. That's what's meant by a square. Now, it would be convenient to sell shingles in bundles of 100 square feet, except it would weigh so much that nobody would be able to pick it up and carry it. So you got to put roofing up on a roof. So what they decided to do was to make that some fraction of 100 feet squared for each bundle, so that you could have an individual bundle that weighed less than the value of the 100 square feet. So it turns out that there are 3 bundles per 100 square feet, 3 bundles per square. Divide 100 by 3 and you get 33.333333 square feet. So that's how many square feet one bundle of shingles will cover. So you take that number, 437.475, which is the total area of the roof plane, divide that by 33.333333 feet squared per bundle, and you get, in this case, 13.1 bundles. That's on one side. We double it to get 26 bundles, and you got to have all of the shingles you need. So we're going to go up one more shingle, which is also going to take care of a little bit of trim and waste. So 27 bundles of shingles and 28 sheets of material will cover that roof. That's it for this.